Now we're going to move on to alternating series. So let me start by giving you some examples. So this is an example of an alternating series. We've seen this in the past. When it's n to the power of 1, it's a special case. Because we use it so often, we assign it a special name. We call it the harmonic series. So if you look at this is very similar to this. It would generate all these terms here. But then the only difference is that here you've got a minus, here you've got a plus. So the only difference is that minus, plus, minus, plus. Up here it's always plus, 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 plus. So this here is an example of an alternating series because it alternates. But when you see this, in your mind, try to isolate this. So in your mind, try to visualize this as one block. So when you see this, when you see this, in your mind, try to isolate this. So in your mind, visualize this. So it's really one block and multiplying another block. So here you can see this is the harmonic series. But because you've got this block here will generate the minus, plus, minus, plus, and so on. Because when n is 1, you put 1 into here. 1 plus 1 will be 2. A minus squared will be a positive. Sorry, hang on. Let's start again. Sorry. When you put 1 into here, it will give you 1. 1 plus 1 will be 2. So minus 1 squared will be a positive. So your first term will be a positive. When n equals 2, you put 2 into here. So when you put 2 into here, it will give you 3. So minus 1 to the power of 3 will be a minus. So this whole thing here will generate a minus term. And then, well, this block here generates your minus, generates your plus, generate your minus, and so on. So this is called the harmonic series. This is called an alternating harmonic series. Okay, so here's another example. So here is another example. The minute you see this, in your mind, you should isolate this bit here. So in your mind, isolate this bit here and visualize this as one fraction here. So this whole thing here will generate this whole series. Notice that you've got a minus, plus, minus, plus, minus, and so on. As it turns out that this thing here will generate this series. As it turns out, this happens to be a geometric series because if you look at this here, you're multiplying. Sorry, hang on. You're multiplying by a half. Here, if you multiply a half, that will then give you this. Here you multiply it by a half, that will then give you this, and so on. So you ignoring the signs. If you just look at these three terms, you know each time you're multiplying by a half. So you know it's going to be something of this form. But then because you've got a change in signs here, minus, plus, minus, and so on. So this happens to be your R here. This happens to be your ratio here, your common ratio. And then because you've got this your first term here. So here you've got this thing here, n equals 1 to infinity. So when n equals 1, you put it into here. So your first term will be negative a half, which is negative a half, which is this, which is this. But then let's try and get it to this. Let's stick a minus 1 into here. So when you put 1 into here, this whole thing here will be 0. So this whole thing here will be 1. So it actually generates this term. But then you started with a negative 2. So let's make your A to be negative 2. The whole point is that this is an example of an alternating series. It would generate all these terms. And it turns out that this whole thing here is a geometric series. It can be written in this form. And we've seen this. If R, the formula for you summing up everything is given by this. So basically, as it turns out, this whole thing here will sum up to this. It's just you applying the formula here. So this is you applying the formula and so on. So the point here is that this is an example of an alternating series. Here's another example. This here is another example. So in your mind, you should try and isolate this bit here. So this would generate your minus, plus, minus, plus, and so on. As it turns out, this series will diverge. It will diverge because if you think about it, you start at 1. You start at 1. So you start at 1. So you start at 1. You then take away 2. So you then take away 2. That will then take you to here. And then you add 3. That will then take you to here. And then you take away 4. That will then take you to here. You see, you're going further and further away. And then you add 5. That will then take you to here. You take away 6, and then that would take you to here, and so on. You're not settling at one point. Let me show you this. Here you will settle at one point. Let's say as it turns out, this alternating harmonic series will actually converge. The normal harmonic series will diverge, which we've seen in the past. But this thing here will converge. Let me illustrate why. So you start. So hang on. Your normal harmonic series, we've seen many times in the past that this thing here will diverge. It will diverge. But the alternating series will actually converge. And let me illustrate why. You start with 1. You start with 1. You take away a half. So this is half. This here is a quarter. So you take away half, and then you come to add something that's smaller than your previous step, a half. So here you would then add a third. Add a third would probably be somewhere around here. And then you take away something even smaller. It's getting smaller and smaller. And then here, and then you add a fifth. That will then take you to here. And then you take away a sixth. And then you add a seventh. Can you see you're settling at a point somewhere? Here, up here, you're going away from a point. You're here. You take away 2, and then you add 3, and then you take away 4. And then you add 5. You're moving further and further away. Whereas here, because each term is getting smaller and smaller and smaller, ignoring the signs. Each term is getting smaller and smaller. So you start at 1, you take away a half, and then you add a third, which is smaller than a half, and then you take away something even smaller, and then you add something even smaller, and then you take away something even smaller. You add something smaller, you take away smaller. Eventually, you can see that you're going to converge. Okay, so this thing here will converge. Okay.